Alright, welcome to Let's Keep Economics Simple. I am Dr. Roland and today's topic is what are sets? Okay, let's start with these questions. What are sets and who invented it? Alright, let's begin and let's keep it simple. Alright, the person who invented this theory of sets, or as we call it, sets theory, is George Cantor. He is regarded to be the founder of sets theory, and set theory is considered to be the foundation for mathematics, as sets theory is used in many other mathematical operations which we will study in the later chapters. Basically, sets can be defined as a collection of distinct elements that have something in common. Okay, so what does that mean? Alright, so let's break it down. In this given pictures, what is common in them? We see that they are group, or we can say bundles or collections, correct? And each of these group or collections are quite distinct. One is a set of eggs, one is a set of pen and spoon and books. So just like that, sets theory help us to organize or group a given data into distinct groups, or we call it sets. That's why sets can be defined as a collection of distinct elements that have something in common. Let's take an example. Typical example of a set looks like this. A set is always represented by capital letter of English alphabet. Example, A, B or C. And the content of the set given under curly brackets are called as elements. For example, 2, 4, 8, 6, 8, 10, A, E, I, O, U. These are the elements of the set. So let's take an example. If you were to build a set of even numbers between 1 to 10, it will look like this. Let's call it, let A be the set. A is equal to, open a curly bracket, 2, 4, 6, 8, 10, close the curly bracket. And all the elements or the numbers within the bracket should be separated by commas. So that is how a set is represented. Let's take another example. Set of odd numbers between 1 to 10. Let's call this set to be B. So from the given numbers between 1 to 10, set B is equal to, open a curly bracket. Since odd number starts with 1, so 1, 3, 5, 7, and 9. Close the bracket, curly bracket. So this will be a set B, which is a set of odd numbers between 1 to 10. Another example. This is an example of a set of English alphabet. It looks like this. Sets can be built, or we can build a set for any such well-defined or distinct element. For example, a set of private schools in Nagaland, set of states in India, set of rivers of India, set of students opting economics in, let's say, XYZ college. So all of these we can build a set for each of this because of the fact that they are well defined and they are distinct. Sets can also be defined as collection of well-defined and distinct objects. So what does it mean by well-defined and distinct set? By well-defined and distinct, we mean clarity in the definition of the elements, or with the absence of vagueness. Let's take an example. A set of vowels of English alphabet. Now that's an example of a well-defined set because an English alphabet has 5 vowels in it, and you cannot expect to have 6 or 7. It just have 5 letters, that is A, E, I, O, U. And now it is distinct because each of the elements are separate and they're distinct to each other, and there is no repetition of the elements, for example. So that's why it is distinct. Therefore, it is an example of a well-defined distinct set. Another example. This type of example will be a set which are not well defined, and therefore they cannot be considered in the study of sets theory. For example, a set of beautiful people or a set of lucky number. Now, these are not well defined because beauty is a relative term, it's a very qualitative term, and it differs from person to person. As they say, beauty lies in the eye of the beholder, and therefore we will not be able to quantify and put it in a mathematical term. Also, a set of lucky number is also a very ill-defined or not well-defined set because of the fact that the lucky number will surely differ from person to person, and therefore such type of sets or elements will be quite vague, and therefore we wouldn't be able to do sets operation, and therefore they are termed as ill-defined or not well-defined set, and such type of sets cannot be considered in the study of sets. So finally, a set can be defined as a set is a collection of well-defined and distinct objects. So with that, we've come to the end of the introduction to this set. So thank you and have a good day.